Many students get hung up on questions that involve subnetting. Once you understand the basics of subnetting, your focus should be to recognize the repetitive characteristics of each problem or situation. This video will provide you with facts, shortcuts, and examples that can be used with IP version 4. Fact number 1. Class A addresses always start with a subnet mask of 255.0.0.0. That's also known as /8. Class B addresses always start with a subnet mask of 255.255.0.0, and that's also known as /16. Class C addresses always start with a subnet mask of 255.255.255.0, and that's also known as /24. Looking at these subnet masks in their different forms, dotted decimal, slash, and binary, you can begin seeing the patterns that will speed up your ability to solve subnetting problems, many times without the need for a paper and pencil. Let's look at an example with /9, /17, and /25. While this is not a normal or classful breakdown of a subnet mask, it allows us to see that the first bit in each octet to the right of its subnet mask has changed from a 0 to a 1. This means that the Class A mask has changed from 255.0.0.0 to 255.128.0.0. The Class B and Class C examples changed in a similar manner. Now, if you look at the example with /10, /18, and /26, you'll see that again, the next bit in each mask has changed from a 0 to a 1. Each time you change the adjacent 0 to a 1, you increase the number of subnets by a power of 2. Look at the second example, the one with /18. 2 bits were changed from 0 to 1, so 2 to the power of 2 equals 4, and that's the number of subnets that have been created. Looking at that example, you've reduced the number of host bits that can be used by 2. So the hosts per subnet were reduced by a power of 2. That is, the 16 bits that were in the Class B default subnet mask that provided around 65,000 IP addresses in a single subnet have been reduced to 14 bits. This results in 2 to the power of 14, or around 16,000 IP addresses per subnet. So you get 4 separate subnets, each having 16,384 IP addresses. Look at the different slash examples, pausing if you need to. Try to recognize the repetitive characteristics that occur as the subnet mask changes. The repetition cycle continues no matter which octet is used. Focus on the 8 bits that are given here. Be certain to identify and remember the default mask that is associated with the problem you're given. Here's some quick tools for subnetting. There are many options used to quickly reference subnet and host boundaries. The examples in this video have been found to be successful in the classroom. Remember that when you're taking the CCNA or any other Cisco exam requiring subnetting, you're provided with a marker and eraser board for notes. We recommend that in addition to any data dump you write before starting your test, you draw out at least the Class C and Class B subnetting diagrams in this video. Normally, the subnetting questions only apply to Class B and Class C ranges. Both of the charts I'll show you will help you answer questions much more quickly, sometimes without the need to work the solution on paper. Look at the Class B chart. You can see the last 2 octets are available for subnetting. The chart has 2 columns of information in the last 2 octets. The bits going from left to right represent the networks, or in this case, subnetworks. The bits going from right to left represent the hosts per subnetwork. So if you borrowed 4 bits from octet 3, draw a line between bit 4 and 5 on the 3rd octet. Looking at the chart, you can see that you have 16 subnets, and each subnet has 4,096 host IP addresses. Now, if you borrowed 5 bits from octet 3, draw a line between bit 5 and 6. You can see that you have 32 subnets, and each subnet has 2,048 host IP addresses. Now let's look at the chart for Class C subnetting. There are 2 columns of information in the last octet. Again, bits going from left to right represent networks, or in this case, subnets. Bits going from right to left represent hosts per subnet. Using this Class C chart and borrowing 4 bits, draw a line between bit 4 and 5. You have 16 subnets, and each subnet has 16 host IP addresses. If you borrow 5 bits, draw a line between bit 5 and bit 6. You now have 32 subnetworks, with each subnetwork having 8 host IP addresses. Taking the time to draw these 2 charts before starting your exam will speed up the time it takes to find a solution to a subnetting problem. Normally, you'll be presented with one of the following types of subnetting questions. Subnet to find a specific number of subnetworks, subnet to find a specific number of hosts per subnetwork, determine the subnetwork assignment for a specific host IP address, determine the type of address that is presented in the question, such as host IP address, network address, or a broadcast address. In this example test question, you have a Class B IP address where 11 bits have been borrowed to create subnets. Based on the subnet mask, you should see that there are 5 bits available for hosts. 2 to the 5th power equals 32. that tells you that there are 32 hosts in each subnet. So the subnetwork would increase by 32. Looking at the address's fourth octet, you see the number .48, which falls between the .32 subnet and the .64 subnet. And you also know that this example, .48 is not a broadcast address. The only logical answer is option 1, which is a usable host address. In this example question, the Class B address again has 5 bits available for hosts, and the subnetworks will again increment by 32. The fourth octet number, .56, falls between the .32 network and the .64 network. This tells you that the subnetwork address would be 172.16.134.32, and that option 3 would be the correct answer. In this third example, you're provided a topology and asked to determine a subnet mask that would be appropriate for use by the company. The number of host bits needed are 5, as this allows 32 IP addresses per subnet. This eliminates option 4, as there are only 16 IP addresses per subnet, and it eliminates option 1, as the subnet mask has 6 host bits. Option 3 is eliminated, since .80 is a host IP address and not a multiple of 32, which is defined by the subnet mask. Option 2 would be the correct answer. Solving subnetting and IP addressing problems can be easy if you recognize the repetitive characteristics and draw subnetting diagrams before starting your exam.